All right, everybody, it is Thursday around noon. This is going to be the key to your Term 1 final test. Remember, your test is going to be an hour in length, and just the typical length of your typical test. There will be some multiple choice and some typical short answer problems. So here we go. Let's work through this, and I would encourage you to scroll ahead to whatever problems you have questions about. So if you don't have any questions about number 1, you got it right. That's totally fine. I would recommend you check against the key first and then watch the video on anything that you missed. So find the value of each expression. We're going to use our order of operations. Remember, the order of operations is PEMDAS. PEMDAS. Okay. And looking at this, we have parentheses. We're going to start with, so this is 9 multiplied by 12 minus 5 is going to give us 7 minus 11 parentheses. Okay, inside these parentheses we have subtraction, we have multiplication. We need to work the multiplication prior to the subtraction. So once you're inside parentheses, PEMDAS is still at play. We have to work multiplication before subtraction. So 21 minus 8 multiplied by 2 is 16. Okay. Let's stay inside those parentheses on the right. 9 multiplied by 7. If you wanted to go ahead and multiply 9 times 7 at this step, you could. Minus 11 multiplied by 21 minus 16 is going to give us 5. Okay. All right. Let's see here. 9 multiplied by 7, that's going to be 63. Minus 11 multiplied by 5, that gives us 55. 63 minus 55 is going to give us a difference of 8. There we go. Number 8 on the first problem, or 8 on the first problem there. All right, moving on to number 2. Evaluate each expression if A equals 10, B equals 8, C equals 6, and D equals 12. All we have to do is substitute, so please do show your substitution. 14 minus A, which is 10, plus B, which is 8. We have subtraction, we have addition. So in PEMDAS, remember with addition and subtraction, they're kind of tied. And the way you break the tie, excuse me, is you work it left to right. So looking at this left to right, we come to the subtraction first, and then the addition second. So we're going to take care of the subtraction first. 14 minus 10 is 4, plus 8, and we get a sum of 12 there. 12 on that problem. Number 3, similar problem. We're going to substitute in for A, B, C, and D. And that looks like this. A multiplied by B, that's going to be 10. Multiplied by B is 8. Minus C, which is 6. Multiplied by D, which is 12. Okay, so we have multiplication. We have subtraction. We have multiplication. We're going to work the multiplication first. 10 multiplied by 8, that is going to be 80. 80 minus let's see here, 6 multiplied by 12, that's going to give us 72. 80 minus 72 is going to leave us with 8. There we go. Number 3, 8x plus 6 is an example of an algebraic equation or algebraic expression. All right, here's the dead giveaway. On an equation, we have an equal sign. Do you see an equal sign here? No. That is an algebraic expression. An algebraic expression contains at least one variable and some operations of some sort. So we have multiplication here and addition. Translate each phrase into an algebraic expression. 7 more than some number. So 7 more is going to be addition than some number. So we'll say x is some number. It doesn't have to be x, could be n or a or whatever. The difference of x and 12. All right, this is going to be subtraction. And the way we're going to work this one out is whatever is listed first, we're going to put that first. So the difference of x and 12. There you go. The difference of, that means we're subtracting x and 12. Okay, name the properties shown by each. Number 6, 22 plus 0 equals 22. So we are adding 0 to a number, and the sum is still whatever number we started with, which in this case is 22. This is the identity property of addition. The identity property of addition. Now, the identity property of multiplication is when we multiply by 1. Just think about this. With the identity properties, whatever you start with, that's what you end with. So with addition, we add nothing to it, and we started with 22, so we finish with 22. With multiplication, if this were 22 multiplied by 1, we started with 22, we end with 22. So with the identity properties, nothing changes there. The multiplicative property of 0, we're multiplying by 0. Whenever you multiply by 0, what happens? The product is 0. So multiplicative property of 0 is when you multiply by 0. Number 7 here. 8 plus, and then in parentheses, 2 plus x is equal to 8 plus, in parentheses, and then plus x. So did the order change? 8 plus 2 plus x, 8 plus 2 plus x. The order did not change. Order is the commutative property. So we know it's not going to be the commutative property. The grouping did change, though. We did have a group of 2 plus x. Now we have a group of 8 plus 2. This is the associative property of, what are we doing? Are we adding or multiplying? We're adding. So that's the associative property of addition. Associative property deals with grouping. Commutative property deals with order. Associative grouping, meaning parentheses, commutative order. Number 8. 4 multiplied by 6 multiplied by 2. 4 multiplied by 6. This time 4 times 6 is in parentheses, multiplied by 2. Did the order change? 4, 6, and 2. 4, 6, and 2. The order did not change. So we know it's not what? Commutative. It has to be the associative property. The grouping changed. It was 6 multiplied by 2 in a group. Now it's 4 multiplied by 6 in a group. That is the associative property of what, you think? We're multiplying, right? So of multiplication. All right. So be able to distinguish between the commutative property where the order changes, the associative property where the grouping changes, the identity property of addition, the identity property of multiplication, and the multiplicative property is 0. So multiplicative property is 0, again, you multiply by 0, and the product is 0. The identity properties, whatever you add to it, nothing changes. So when we add 0, nothing changes. 22 plus 0 is 22. And then for the identity property multiplication, 22 multiplied by 1 is still 22. Simplify each expression using the distributive property. Okay, so here we have in a group b plus a. So these two terms inside the parentheses, they have to be separated by addition or subtraction. If it's separated by multiplication, we do not use the distributive property. Only when there's addition or subtraction in the parentheses. So 7 multiplied by b is 7b. 7 multiplied by a is 7a. Plus 4 multiplied by 2a is 8a. 4 multiplied by 3 is 12. Plus 7b. Now we combine like terms. 7a, 8a is 15a. Plus 7b plus 7b, that's 14b. And then plus 12 can't be combined with anything. So remember, we can only combine the a terms with the a terms, the b terms with the b terms, and the constant can't be combined with any variable terms there. Number 10, 6 multiplied by x is 6x. 6 multiplied by 2y is positive 12y. Plus 2 multiplied by 7x is 14x. 2 multiplied by 2y is 4y. Plus 3x plus 8. Let's combine like terms. Let's start with the x's. 6x plus 14x is 20x. 20x plus 3x is 23x. 12y plus 4y is 16y. And then plus 8 can't be combined with anything. So there we go. 23x plus 16y plus 8. Okay, identify the solution to each equation from the list. So for each of these, we're going to sub in and determine which is true. So here we go. 15 minus 12, is that equal to negative 3? So we subbed in 12, right, for x? No, that's not true. So 12 is not the solution. How about 15 minus 18? Is that equal to negative 3? And yes, it is. So 18 is the solution there. How about 15 minus negative 12? Is that equal to negative 3? 15 minus negative 12 is 15 plus 12. That's going to be 27, which is not equal to negative 3. So negative 12 is not a solution either. Same thing on 12. Number 12 looks like this. 35 over x plus 2. So it's going to be 3 plus 2 is equal to 5. Okay, let's simplify this. 35 over 5, is that equal to 5? Well, 35 divided by 5 is 7. So those are not equal to each other, right? Should do this as well. Those are not equal. So that was a 3 we subbed in, so that is not the value for x that makes that equation true. 35 divided by 5 plus 2. I should remind you also that in a problem like this, there are implied parentheses in the denominator and the numerator. So any operation in the denominator, we need to work before we take care of that division. So in this case, we do need to add before we divide because of those implied parentheses. Okay, we get 35 over 5 plus 2 is 7. And that is in fact equal to 5. So 5 is going to be my solution here. And just really quick, let's sub in 7 mentally. 7 plus 2 is 9. 35 divided by 9 is not 5. So 7 is not the solution there either. All right, use ordered pairs. Use the grid on the right to name the point of each ordered pair. Okay, so let's see here. Let's start with A. A is located at, we start at the origin, we go to the right, 1, 2, 3. So my x coordinate is going to be 3. And then my y coordinate, I have to go down 2. So down 1, down 2. So the y coordinate is going to be negative 2. For B, B is located at, starting at the origin, I go to the right 1. So my x coordinate is going to be 1, and I don't go up or down at all. So 1, 0. For C, I don't go left or right at all from the origin to get to C. So my x coordinate is going to be 0. And to get to C, I have to go down 2. So down 1, down 2. So that's negative 2. D. To get to D, starting from the origin, I have to go to the left. 1, 2, 3. So that's going to be negative 3. And I have to go up 1. So up 1. There you go. E. To get to E, I have to go to the left. 1, 2. So that's negative 2 for the x coordinate. And I don't go up or down at all, so 0. And then for F, I don't go left or right at all, so 0. And I go up 1, up 2. There you go. Those are those 6 points. All right, number 12, the inverse operation for subtraction is addition. The inverse of subtraction is addition. Solve each equation using the inverse operation. Okay, 84 equals 12 multiplied by x. What is happening between the 12 and the x? Multiplication. What is the inverse of multiplication? Division. So I need you to show this division just like this. All right, very good. Now 84 divided by 12, that is 7. 7 is equal to x. So this is the amount of supporting work I need to see. I need to see the inverse operation. I don't care if you show the long division or not. If you can do 84 divided by 12 mentally, that's okay with me. It doesn't matter if the x goes on the left side of the equation or the right side of the equation. Both of these are the same thing. Okay. Number 14, 18 plus y equals 7. What is happening between the 18 and the y? Addition. What's the inverse of division? I'm sorry, back up. The inverse of addition. The inverse of addition is subtraction. So I'm subtracting 18 from both sides. Show this on both sides of the equation. Please don't show it on one side and not the other. So check your work. Make sure you showed the the division of the previous problem on both sides. Make sure you show the subtraction from this problem on both sides of the equation. So we get y equals 7 minus 18. 7 minus 18. Okay. Which number is further from 0, negative 18 or positive 7? Negative 18 is. So we know this is going to be negative. How far apart is 18 from 7? How far apart are 18 and 7? They're 11 apart. So y is equal to negative 11. All right, number 9. 9 is equal to x, sorry, that was number 15 we're on now, number 15. 9 is equal to x divided by 12. What's the inverse of division? Multiplication. So we multiply by 12. Please show this multiplication in the numerator here. Don't show it hanging out down here in the denominator. And we multiply by 12 on the left side of our equation as well. What I do to one side of the equation, I have to do to both. Otherwise, it gets out of balance. Okay. So let's see here. 9 multiplied by 12. It's going to be 108 is equal to, all right, 12 divided by 12 here. 12 divided by 12 is 1, so we're left with 1 times x, which is just x. All right, there you go. 108 is equal to x. The product of a number and 7 is 96. Product means we're going to multiply. We'll say a number is x. The product of a number, x, and 7, we're multiplying x and 7 is equals 96. There we go. What is happening between the x and the 7? Multiplication. So 7x, we divide by 7 on the left. 96, we divide by 7 on the right. All right, so 96 sevenths. I would take this as an answer. This is not 96 is not evenly divisible by 7, so I would take 96 sevenths. That's fine. Or let's see here. 7 times 11 is 77. We just saw over here 7 multiplied by 12 is 84, which means 7 multiplied by 13 has to be, it's 84 plus 7, 91. So it's going to be 13. And if we take 91 away from the 96, we're left with 5 sevenths, right? So there you go. That, oops, excuse me. Or you might say 96 sevenths. Either of these is okay. All right, very good. All right, multiple choice here. Choose the letter of the term. This is in chapter 2 now. Choose the letter of the term that best matches each statement or phrase. We have absolute value, additive inverse, coordinate, graph, integers, negative integers, and quadrants. Okay. 18. The 4 regions separated by the axes on a coordinate plane. The 4 regions are called, 4 is the key word there, quadrants. So G quadrants there. Number 17, an integer less than 0. An integer less than 0. Well, once you go to the left of 0 or less than 0, that's a negative number. So F, negative integer there. Oh, looks like 17 and 18 got mixed up. Sorry about that. Number 19, the number that coordinates with a number on a number line. The number that coordinates, keyword there's coordinates, with a number on a number line, that's going to be the coordinate C. 20, an integer and its opposite. An integer and its opposite. Well, it's going to be additive inverse, B. So like if I gave you the number, so if I gave you the number negative 4, and I said, what is the additive inverse of negative 4? What that is saying is negative 4 plus something is equal to 0, so negative 4 plus 4 is equal to 0. Conversely, if I gave you the number 4, and I said, what is 4's additive inverse? So 4 plus something equals 0. That's got to be negative 4, right? So 4 and negative 4 are additive inverses of one another. A number that you can add to another number that makes it sum equal to 0. Positive and negative whole numbers. That would be integers, E. Integers, positive and negative whole numbers like 0, 1, 2, 3, forever. And also negative 1, negative 2, negative 3, forever in that direction as well. Those are the integers, positive and negative. All right, a dot placed at the point named by the ordered pair. If I told you to graph something, that means you're putting a point on a graph, right? So you're putting a dot at a point named by the ordered pair that is graphing something. 23. The distance a number is from 0 on a number line, that is going to be a number's absolute value. So how far a number is from 0, a number's distance from 0 is its absolute value. Graph each set of numbers on a number line. Okay, so we go up to 11, I see. How many dots do I have? Well, how low do I go? I go down to -4, and I go up to 11. So I need, let's see here, that's 12 plus 4. I need 16. How many dots do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yeah, I got plenty. Okay, so we'll do this. We'll say -3. That makes this negative. We'll do every other one, right? That makes this -5, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So there you go. Let's put these points on the number line, and when I do that, it looks like this. -3. All right, just put a dot there at -3. There we go. 4. 4 is between 3 and 5. -4. -4 is to the left of -3. 0. 0 is between -1 and 1. 11. 11 is here. -1. I've already done -1. Hang on. Oh, no, I haven't done that. I did 0. Excuse me. -1 is here next to 0. There we go. Let's make sure I got them all. -3, -3, 4, 4, -4, -4, 0, 0, 11, 11, -1, -1. All right, good. Number 25, find the absolute value. Remember, absolute value is always positive. So if the number is already positive, it stays positive. If the number is negative, it becomes positive. And that's what's happening on 25 here. The absolute value of -41 is 41. There you go. Let's just leave it as 41. Number 26. Okay, on 26, we take the absolute value of -41, giving us 41, right? So it comes out positive, but what's waiting for it on the outside? This negative sign. So this negative sign gets applied to the 41 after it comes out. Boom, -41 is what we get there. Number 27, absolute value of 18 minus the absolute value of -21. So let's do the same thing to start out. That's going to be 18 minus the absolute value of -21 is 21. 18 minus 21 is -3. -3 there. Okay, now on number 28, we have some operations to do inside the absolute value. You treat the absolute value kind of like you would parentheses. If there's any operations to be done inside the absolute value, you do those first. So the absolute value of, what is 18 minus 21? -3. And then we take the absolute value of -3, which gives us 3. There we are. If you got tripped up on this one, it was probably, I would think, 26 and 28, but hopefully you're watching the video. Replace each with less than, greater than, or equal to. Okay, 12 and -12. These are not equal. 12 is greater than -12. Number 30, -12 and -21. These are not equal. -12 is greater than -21. If you plot these on a number line, -12 is further to the right. Numbers further to the right are larger, right, greater than the numbers to their left. Number 31. Okay, the absolute value of -12 is going to be 12. Comparing that to 12, these are equal to each other, so these must be equal to each other. Order the integers in each set from least to greatest. So this is going to be -21, -12. I think that exhausts all our negative numbers. 0 is next, 12, and 21. We ordered them from least to greatest. Just do your best with the set symbols. If they're not perfect, that's okay. Number 31, we have some negative numbers. We have -12, that's the furthest to the left. then -5, then -3, 0, 3, 8. Make sure I got them all. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, I like it. Set and set. All right, number 32. Complete the following sentences. To add integers with the same sign, add their blank. The sum has the blank sign as the add-in. So think about positive numbers like 4 plus 3. 4 plus 3 is just 4 plus 3, which is 7. What about -4 plus -3? Well, -4 plus -3, they have the same sign. That's going to be -7. So you add their absolute values. The sum has the blank sign as the add-ins. What do you think? 4 plus 3 is 7. -4 plus -3 equals -7. Has the same sign as the add-ins. Number 33. To add integers with different signs, find the difference of their blank. The sum has the same sign as the add-in with the blank absolute value. Okay. So let's think about, let's do 4 plus -7. 4 plus -7. This would be -3. Well, how do we do that? Which number has the larger absolute value? -7 does. So we know it's going to be negative. And then how far are 4 and 7? They're 3 apart, so -3. So to add integers with different signs, find the difference of their absolute values. That's what I did when I said how far apart are 4 and 7, right? I didn't say -7. I said how far apart are 4 and 7 if they're 3 apart. The sum has the same sign as the add-in with the larger, right? -7 is further from 0, absolute value. So there you go. 34. Solve each equation. G is equal to, all right, 18 plus -25. -25 is further from 0, so we know this is going to be negative. How far apart is 18 and 25? They are 7 apart. G is equal to -7. Number 35. X is equal to, okay, 7 plus -3. Which number is further from 0? 7 is. Okay. And then how far apart are 7 and 3? They're 4 apart, so that's going to be 4. And then bring down the plus -14. Let's do it all over again. Which number is further from 0? 4 or -14? -14 is, so we know this is going to be a negative sum. How far is 14 from 4? They are 10 apart, so this is x equals -10. 36 is worded kind of funky. To subtract an integer, add its, so we're thinking about subtraction as addition. So like think about 4 minus 7. 4 minus 7 is the same thing as 4 plus what? -7. So to subtract an integer, add its opposite. Okay. Solve each equation. X is equal to -18 minus -7. This is -18. When you subtract a negative, you have to add plus 7. X is equal to, all right, what's further from 0, -18 or 7? -18 is, so we know that sum's going to be negative. How far is 18 from 7? They're 11 apart, so x equals -11. Number 38, h is equal to 15 minus -16. This is 15. You have to add when you subtract a negative. 16. H is equal to 15 plus 16 is 31. 31. Simplify each expression. Okay, we follow the same rules when there's variables involved. -15x. When you subtract -21, we have to add 21. Don't forget the x. This is equal to, all right, -15 plus 21. Which number is further from 0? 21 is. All right, and how far is 21 from 15? They are 6 apart, so that's 6x on that one. Number 40. 12t minus 5t. What's 12 minus 5? It's 7. So we get 7t there, 7t. Number 41. -6ab minus -11ab. So -6ab, these are like terms. we have the same variables, a and b. When we subtract a negative, we have to add 11ab. Okay, what's further from 0? Negative 6 or positive 11. Positive 11 is, so we know the sum's going to be positive. How far is 11 from 6? They are 5 apart. So 5ab is what we get on that problem. Stop that. Multiply integers. Complete each sentence. The product of two integers with different signs. So think about like 4 multiplied by negative 3. The product of two integers with different signs is negative 12 in this case. So negative. The product of two integers with the same sign, well, negative 4 multiplied by negative 3. A negative multiplied by a negative is a positive 12 in this case. It's a positive. And it's the same thing with positive 4 multiplied by positive 3. That's going to be positive 12. So solve each equation. X is equal to, here we have a negative multiplied by negative, which is going to be positive. 3 times 5 is 15. Carry down, actually, you know what? Here's what I can do. Negative 1 times negative 1. What's a negative times a negative? A positive. What's 1 times 1? 1. What's 15 multiplied by 1? 15. There we go. 46. Negative 26 multiplied by negative 3 multiplied by 2. What's a negative multiplied by a negative? A positive. What's 25 multiplied by 3? 75. So 75 multiplied by 2. What is 75 multiplied by 2? 150. 150 on that one. Let's keep on moving. Find each product. Negative 2 multiplied by 8z multiplied by 3. What's a negative multiplied by a positive? A negative. What's 2 multiplied by 8? 16z multiplied by 3. What's a negative times a positive? A negative. What's 16 multiplied by 3? Well, that's 16, 32, 48. So that's negative 48z. Number 48. Negative 6x multiplied by negative y. A negative multiplied by a negative is a positive. What number is in front of this y here? It's negative 1, right? So what's 6 times 1? It's just 6. Negative times a negative is a positive, so we get 6xy. Boom. Number 49. Negative 15x multiplied by positive 5y. A negative multiplied by a positive is a negative. 15 multiplied by 5 is 75. 75. And then x multiplied by y is just x times y. All right, moving on to chapter 3, solving one-step equations and inequalities. Number 49, when two numbers, true or false, when two numbers that are additive inverses of each other are added, sum is 0. So think about additive inverses. 4 plus negative 4 equals 0. Right? Negative 5 plus 5 equals 0. That is true. Additive inverses are the same numbers, just different signs, and by definition their sum is 0. Number 50, a solid dot on a number line indicates that the point is included in the solution set. So think about like if we were graphing something like, I don't know, x is greater than 5, we would have an open circle at 5 and we would shade to the right. But if it were x is greater than or equal to 5, we would have to shade in the 5, indicating that the 5 is included in the solution set. That is true. Number 51. The division property of inequality says that if you divide both sides of an inequality by the same number, the order of the inequality remains the same. The division property of inequality states that if you divide both sides of an inequality by the same number, the order of the inequality remains the same. So think about when we divide both sides of an inequality, that's like a greater than, less than, greater than or equal to, less than or equal to. When we divide by a negative, what do we have to do to our sign? We have to flip it. So that's false. It doesn't remain the same. We have to flip the sign to make it true again. 52. Solve each equation and check your solution. Then graph the solution on a number line. We're going to subtract 31 from both sides. The inverse of addition is subtraction, so we get x is equal to, this is negative 82. All right, now on your test, I'm not going to ask you to graph on a number line. I should have crossed this out. I'll cross it out now. If you were to graph this on a number line, just so you know, if you're wondering, it's just this, negative 82, right? There's negative 81, there's negative 83. It's just a dot. That's all it is. We're not going to do that, but that's how it is to be done. 54. Negative 12 minus k is equal to negative 7. Okay, with this one, what's the inverse of negative 12? We have to add 12 to both sides, plus 12 and plus 12. Now on the left side, the sign in front of the k, it belongs to the k. You have to leave it there. So negative k is equal to, what is negative 7 plus 12? That's 5. So if negative k is equal to 5, k has to equal negative 5. All right. Number 53. Let me change colors here. 53. Y is equal to, this is easy enough, negative 11 plus 40. Which number is further from 0? 40 or negative 11? 40 is, so we know it's going to be positive. How far is 40 from 11? In other words, what's 40 minus 11? It's 29. 29. All right, this next one here, 16 is equal to x. You subtract negative 4 and you have to add x plus 4. What's the inverse of addition here? Subtraction. So we subtract 4. 4 minus 4 is 0. You subtract 4 on the left side as well. Make sure you are showing your inverse operations on both sides. We get 12 is equal to x. 12 is equal to x there. Number 56. Solving equations by multiplying or dividing less than 3.3. Solve each equation and check your solution. These are equations. What's happening between the negative 12 and the x here on 56? That's multiplication. What's the inverse of multiplication? Division. So I divide by negative 12 on both sides of that equation, and we get x is equal to, what's a positive divided by a negative? A negative. Let's see here, that's going to be 8. Negative 8, right? 8 multiplied by 12 is 96. Yep. Okay, good. Number 58. 14 multiplied by x. Other side of the equation is 196. What's happening between the 14 and the x? Multiplication. What's the inverse of multiplication? Division. So we divide by 14 on the left and on the right side. All right, let's see here. Let's see. 14 times 10 is 140, and then we've got 56 to go. So that's 14, 28, 42, 56. That's going to be 14. 14 is equal to x there. You could do long division for that one, but it is going to be 14. Let me double check. Yeah, 14. All right, 57. X divided by negative 11. What is happening between the x and the negative 11? Division. What's the inverse of division? Multiplication. So we multiply by negative 11. Again, please show this multiplication up in the numerator, not the denominator. We multiply by negative 11 on both sides. And we get, by the way, a negative divided by a negative is a positive, so we're left with positive x equals, on the right side, a negative multiplied by a negative is a positive. 15 multiplied by 11 is going to be 165. 165. Stop doing that. Okay. Number 59. All right, we've got a negative sign out front. And remember, we want to solve for q, and we want q to be positive here. So to make this left side positive, I have to multiply by negative 8. Right? The inverse of division is multiplication, and a negative times a negative is a positive, so I'll be left with just positive q. But remember, we have to also multiply by negative 8 on the right side. A positive multiplied by a negative is a negative. 12 multiplied by 8, that is 96. Q is equal to 96. Lesson 3.6, solve each inequality and check your solution. Pardon the typo there. Then graph the solution on a number line. I should have also included that you should write inequality notation, not inequality notation, interval notation. So I'll put that on Google Classroom as well, but hopefully you're watching this and you're checking your answer against the key. So we're going to add 2 to both sides here, plus 2 plus 2. We are left with x is less than negative 14 plus 2 is negative 12. We only flip the sign when we multiply or divide by a negative. We didn't multiply or divide by a negative here. So on our number line, we'll just do this briefly. Negative 12. This is going to be negative 11. This is negative 13. Open or close circle at negative 12. Open. X is less than negative 12, so we shade to the left. Remember to have your variable on the left side of the inequality. It worked out that way this time. We didn't have to switch it around or anything like that. Number 64. 12 plus t is greater than negative 9, so we're going to subtract 12 minus 12 minus 12. T is greater than, what's negative 9 minus 12? Negative 21. T is greater than negative 21. There we go. Negative 21, negative 20, negative 22. Open circle at negative 21 because it is greater than. Do we shade left or right? Shade to the right. Shade to the right. T is greater than negative 21, so it's all those numbers to the right of 21. Is negative 21 included in our solution set? Yes or no? What do you think? Is negative 21 included in the solution set? Well, is negative 21 greater than negative 21? No, they're equal. So that's why we have an open circle there at negative 21, is to show that all the numbers right up next to negative 21 are included, but not negative 21 itself. Number 65, we're trying to solve for g. What's happening between the g and the negative 7? We are adding, but I need to add the additive inverse of negative 7. To do that, I'm going to add 7. Negative 7 plus 7 is 0. I'm going to add 7 on the left side as well. And we get 2 is greater than or equal to g. Now here's a problem where we have g on the right side of the inequality. We need to flip this around, so g is on the left, 2 is on the right. When I do that, I got to flip that sign to less than or equal to. There you go. We have 2, we have 3, we have 1. Open or close circle at 2. Close circle at 2. Do I shade left or right? Shade left. There we go. Let's keep on moving. 4 is less than or equal to y minus negative 23. So that's 4 less than or equal to y plus 23. If I'm going to solve for y, I have to subtract 23 from both sides. And we're left with, that's going to be negative 19 less than or equal to y. We need to flip this around. Y negative 19. Flip the sign as well. Y is greater than or equal to negative 19. On the number line, looks like this. Negative 19. This is negative 18. This is negative 20. Open or close circle at negative 19. Close circle. Do we shade left or right? Greater than, we're going to shade to the right. To the right there. Number 67. Okay. X, let me change to red here. X plus 10 minus negative 4 is going to be plus 4 is greater than negative 12. All right, we should combine like terms first. So when I do that, I get x plus 14 is greater than negative 12. Okay. We're now going to, let me change to green actually. Subtract 14 from both sides. So x plus 14 minus 14 is greater than negative 12 minus 14. We end up with x is greater than negative 26. So if you're wondering what's going on with this one, the first thing I did was I saw I'm subtracting a negative, so I changed that to addition. I combined my like terms, and then I solved for my variable x. So x is greater than negative 27. There we go. Let's put this on a number line. There we go. Negative 26, that'd be negative 25. Negative 27, open or close circle at negative 26. Open, shade left or right. Shade right. Greater than, we shade to the right. All right, number 68. We're going to subtract 9 from both sides to solve for w. W is less than negative 14. So on my number line here, negative 14, negative 13, negative 15. Open or close circle at negative 14? Open. Shade left or right? Left. We did not do our interval notations. Let's go back and do that now. Back to number 63. All right, we're shading to the left, so we're going all the way to the left. That's our low end, which is negative infinity, and the high end is negative 12. Infinity always gets a parenthesis. That's an open circle, which means that gets a parenthesis as well. Okay? Looking at, hang on, let me draw an arrow here. Something like this. There. Looking at number 64, negative 21, is that the high end or low end? Negative 21 is the low end. It goes to the right forever. So the high end is positive infinity. Infinity always gets a parenthesis. And negative 21, that is an open circle, so it also gets a parenthesis as well. On to 66. Looking at our graph here, negative 19, is that the high end or low end? That's the low end. How high does this go? It goes to the right forever, so that's infinity. Infinity always gets a parenthesis. And negative 19 is a closed circle, so it gets a bracket. Closed circles get brackets. On to number 65. This goes to the left forever. So the low end is negative infinity. Okay. The high end is going to be 2. Infinity always gets a parenthesis. 2 is a closed circle, so it gets a bracket. We'll put this in a box here. Something like that. And put this in a box too. There we go. Let's keep going. On to number 68, negative 14, high end or low end? It's the high end. That's the furthest point to the right, which makes the low end, goes to the left forever, negative infinity. Infinity always gets a parenthesis. That's an open circle at negative 14, so it is also a parenthesis as well. Number 67, negative 26, is that the high end or low end? It's the low end. Right? It's the point furthest to the left. It's an open circle, so it gets a parenthesis. And it goes to the right forever, so infinity is the high end. Infinity always gets a parenthesis. There we go. So there's your interval notation as well. All right, 69 through 74, we are dealing with division and multiplication. Remember, when we multiply or divide on both sides by a negative, we have to flip our sign, and that happens on number 69 here. Let me step off to the left. X over negative 15. We're going to multiply by negative 15. 9 multiplied by negative 15. Now, when we multiply by a negative, I have to flip my sign. In this case, from less than to greater than. So we get X is greater than. Positive times a negative is a negative. 9 times 15 is going to be 135. 135. There you go. On the number line, negative 135, negative 134, negative 136. Open or closed circle at negative 135? Open circle. Do I shade left or right? Shade to the right because it's greater than. All right, negative 135, is that the high end or low end? That is the low end, negative 135. What's the high end? Infinity goes to the right forever. Infinity always gets a parenthesis. Negative 135 gets a parenthesis as well. Number 70. Again, we have a negative. We're going to have to divide by a negative, so let me step off to the left here. Negative 72, negative 4x, I'm going to divide by a -4 on both sides. And when I divide by a negative on both sides of an inequality, you have to flip your sign from greater than or less than this time to less than or equal to this time. I'm sorry, it was greater than or equal to, I should say. It was greater than or equal to, now it is less than or equal to. All right, a negative divided by a negative is going to be a positive. 72 divided by 4, let's see here, 4 times 20 is 80, so we're 8 short of that, so it's going to be 18. Everybody see that? 4 times 20 is 80. We're 8 short of 80, so that's 2 groups of 4, so that's 8. Less than or equal to x. Let's flip this around. X is greater than or equal to 18. There we are. On the number line now, 18. Let's call this 19 and 17. Open or close circle at 18. Close circle. Do we shade left or right? Shade to the right. There we go. Any interval notation? 18 is at the high end or low end. It's the low end. It goes no further to the left than 18. What's the high end? Infinity. Infinity always gets a parenthesis, and 18 is going to get a bracket because it is a closed circle. So 18 is included in the solution set. Let's keep on moving. Number 71. 71. All right, no negative here, so we just multiply both sides by 12. Come on now. Y divided by 12. We're going to multiply by 12 on the left, and we're going to multiply by 12 on the right. We end up with y is greater than, what is this going to be, 132. 132. Number line. Here's 132. 133. 131. Open or close circle at 132. Open circle. Y is greater than 132, so we shade to the right. Okay. 132 is at the high end or low end. That's the low end. So 132. What's the high end? Infinity. Infinity always gets a parenthesis. 132 gets a parenthesis. There we are. And here we are as well. I don't think I boxed in my interval notation on the previous problem. I did. Okay, good. Number 72. 5 multiplied by x. We're going to divide by 5. That looks like this. Divide by 5. Divide by 5. We don't flip our sign because we're not dividing by a negative, so x is greater than negative 15 divided by 5 is negative 3. There we go. Let's graph this now. Negative 3. Here's going to be negative 2. This is negative 4. Open or close circle at negative 3. Open circle. X is greater than negative 3, so we shade to the right. Shade to the right. All right. Negative 3 is at the high end or low end? It's the low end, negative 3. And if we go to the right forever, that is going to be infinity. So parenthesis around infinity, and that's an open circle, so parenthesis around negative 3 as well. Number 73. All right, here we have a negative. We're going to have to multiply by negative 12 on both sides. So let me step off here to the left. This is negative x over 12. Remember, it doesn't matter where we put this negative. It can be up top, down below, or in the middle, just as long as there's only one of them. So we're going to multiply by negative 12 on the left, and then 8 multiplied by negative 12 on the right. When you multiply by a negative on both sides, we have to flip our sign. It was less than or equal to. Now it's going to be greater than or equal to. So a negative multiplied by a negative is a positive. 12 divided by 12 is 1. We're left with x is greater than or equal to. A positive multiplied by a negative is a negative. 8 multiplied by 12 is 96. So x is greater than or equal to negative 96. On my number line, it looks like this. Negative 96, negative 95, negative 97. Closed circle at negative 96. We shade to the right. X is greater than or equal to negative 96. Now, interval notation. At negative 96, we're going to have that's the low end, negative 96. The high end is infinity, shades to the right forever, parenthesis around infinity, and that's a closed circle at negative 96, so we get, say, bracket. There we go. Last one here, 74. This is negative 1 multiplied by x is less than 2. So we're going to have to divide by negative 1 on both sides. I know this doesn't seem like you have to do this. Why can't we just say x is less than negative 2? Well, what you're actually doing mathematically is you're dividing by negative 1. So we do have to flip that sign. And it looks like this. That is a negative 1 for the coefficient of x. So we get x is greater than 2 over negative 1 is negative 2. There we go. X is greater than negative 2. Let's put this on a number line. Negative 2, negative 1, negative 3. Open or close circle at negative 2. Open circle. X is greater than negative 2, so we shade to the right. X is greater than negative 2, so we shade to the right. And negative 2 is at the high end or low end? It's the low end. We shade to the right, so that's infinity on the high end. Parenthesis around infinity, open circle, which means negative 2 is not included in the solution set, so parenthesis around the negative 2. There we are. Applying equations and inequalities, lesson 3.8. 75. 4 times a number is greater than 76. What are the numbers? Graph the solution on a number line. Define a variable. So 4 times a number, x equals a number. Okay? Doesn't really represent anything other than a number. So 4 times a number, 4x, is greater than 76. 4 times a number is greater than 76. Let me give myself some room to work here. I'll do this in red. 4 times that number is greater than 76. We divide both sides by 4, so that looks like this. 4x divided by 4. We don't have to flip our sign because 4 is positive, not negative. X is greater than, all right, well, 4 times 20 is 80. So this is 4 short of that, so it's going to be 19. X is greater than 19. Graph the solution on a number line. 19. Open circle, shade to the right. This is 20, this is 18. There you go. Next one. Fred. Fred needs at least 86 points to pass Eileen's scores. Eileen has 631 points. How many points does Fred have? Okay, so to pass Eileen. Okay. So it doesn't say he's 86 points down. It says to pass Eileen, he has to get 86. Okay, this one's a little tricky because if he needs 86 to pass her, what does he need to tie her? He needs 85, right? So Fred has 85 less than Eileen. So that's going to be Eileen's, we'll say F equals Fred's points. Fred's points. Okay, and so Fred's points plus 86, but we're going to make it 85 because 86 passes her. 86 will tie her, equals 631. Again, the reason we didn't add 86 was if we added 86, he would be more than Eileen. So we could have either done F plus 86 equals 632, or we could have done F plus 85 equals 631. You end up with the same answer either way. So we subtract 85 on both sides, minus 85, minus 85. And Fred has, let's see, let's subtract 5, that's 626. And then subtract 80, that is 546. 546, let's check this one more time. Subtract 5 and you get 626. Subtract 80 from 626 and you get 546. Yeah, I like it. Fred has 546 points. There you go. The blank of a whole number divides that number with a remainder of 0. That'd be factor. The factor of a whole number. So think about 12, right? What's the factor of 12? Well, 3 is a factor. We can divide it by 3 and we get 4. We can divide it by 6 and we get 2. We can divide it by 2 and we get 6. So 3 is a factor, 6 is a factor, 2 is a factor, also 12 is a factor, 1 is a factor as well, 3 is a factor. A blank is an integer, a variable, or a product of integers and variables. So an integer, that'd be like x. A variable, an integer would be like -5. A variable would be like x. And the product of integers or variables, that'd be like -5 multiplied by x, right? These are all monomials. Monomials. Remember, it's a monomial, and the dead giveaway of whether it's not a monomial is if you see any addition or subtraction. All right. Factors and monomials. Using the divisibility rules, state whether each number is divisible by 2, 3, 4, 5, 6, 9, or 10. So I like to write them out. You don't have to do this. 2, 3, 4, 5, 6, 9, 10. Okay, I can tell right away it's even, so it's not going to be 2. It's not going to be 4, not going to be 6, not going to be 10. Once it's not even, you can mark out all the even numbers. 3, the rule for 3 is you add up all the digits, and if that sum is divisible by 3, then the number itself is divisible by 3. So 2 plus 3 is 5, 5 plus 1 is 6. So yes, it is divisible by 3. It is not divisible by 5 because the rule has to end in 0 or 5. And then 9 is, you add up, the rule for 9 is you add up the digits, and the sum needs to be divisible by 9. 2 plus 3 is 5, 5 plus 1 is 6. 6 is not divisible by 9. All right, let me do the next one in red. 2, 3, 4, 5, 6, 9, and 10. Okay, this is even, so I'm going to circle 2, but I notice it does not end in a 5 or a 0. I'm going to eliminate 5. I'm going to eliminate 10. All right, let's take a look at 3. 1 plus 9 is 10. 10 plus 6 is 16. 16 plus 2 is 18. So 18 is divisible by 3. And it's also divisible by 9. So I'm going to circle 3 and 9. The rule for 6 is if 2 and 3 are circled, you should also circle 6. So this is also divisible by 6. And then 4 is the last 2 digits, which is 62. So let's think about this. 4 times 10 is 40. 4 times 20 is 80. 4 multiplied by 15. Okay, well that's like 10 and 5, right? So 4 times 10, 40. 4 multiplied by 5, 20. 20 and 40 makes 60. So the multiples of 4 are going to go 60 followed by 64. So 62 is not divisible by 64. You can check me out with long division if you want to. All right. 2, 3, 4, 5, 6, 9, and 10. I can tell right away it ends in a 0, so I'm going to circle the 5. I'm going to circle the 10. I'm also going to circle the 2. The last 2 digits are 20. The last 2 digits are 20, so the rule for 4 is the last 2 digits need to be divisible by 4, and 20 is, so I'm going to circle 4 as well. All right, let's take a look at the rule for 3. 4 plus 6 is 10. 10 plus 2 is 12. So 3 is divisible by 12, but 9 is not divisible by 12. The rule for 6 is if 2 and 3 are circled, 6 should also be circled as well. In other words, if a number is divisible by 3 and 2, it is also divisible by 6. So there you go. Number 83. Ooh, it's taking a long time. 83. Write each multiplication expression using exponents. When you're dealing with negatives like this, you do need to include parentheses around the negative. This is -5 to the power of 1, 2, 3, 4, 5. -5 to the power of 5. This on the left side of the equation is called expanded form. This on the right side of the equation is called exponential form. Okay. I think this is a typo on this one. So let's say this is 2 minus y, okay? Let's do that. Sorry about that, guys. Hopefully you aren't too confused on that. So this is 2 minus y to the power of 3. Yeah, if you look at the keyboard, the y is right next to the 7s, I think. Just that finger went a little too high. Number 85, let me change colors for 85 so it doesn't blend in too much. All right, write using exponents. 3 times 3, that is 3 to the power of 2. Multiplied by, I'm okay with you writing 5 or 5 to the power of 1, either way. Multiplied by x to the power of 1, 2, 3, x to the power of 3. Multiplied by y to the power of 2. Number 86, write each power as a multiplication expression. In other words, in expanded form. Write these in expanded form. So this is going to be negative 12 multiplied by negative 12 multiplied by negative 12 multiplied by negative 12 multiplied by negative 12. That's 5 of them, right? Negative 12 to the power of 5. 1, 2, 3, 4, 5. Got it. You might be asking, Mr. Rivers, do I have to include parentheses here? When you're writing out an expanded form, you can. You don't have to, though. So when in doubt, use them. 87, 4x to the power of 3. This is going to be 4x multiplied by 4x multiplied by 4x, which is going to be, you might write it like this, 4 times 4 times 4 times x times x times x. I would take either of these. Either is okay. 4. Okay. Write each number or monomial, or factor each monomial or each number or monomial completely. 120. This is 2 multiplied by 60. 60 is 2 multiplied by 30. 30 is 2 multiplied by 15. 15 is 3 multiplied by 5. So 120 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 5. There it is in expanded form. In exponential form, 2 to the power of 3 multiplied by 3 multiplied by 5. So there you go, prime factorization, and there's your factor tree. All right, the next one, let me do this in blue. Negative 342. We're going to factor out a negative 1. 342. So this is going to be 2. And then this is 171. 171. Let's do our rule for 3. 1 plus 7 plus 1 is 9. We can divide that by 3. Let's see here. This is going to be 57. 57. 57, let's check for 3 again. 5 plus 7 is 12. We can divide this by 3 again. By 3 again. That's going to be 19. 57. Yes. So 19 is prime. So 2, 3, 3, and 19. So negative 342 is equal to negative 1 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 19 Oh, I forgot the variables. Hang on. Negative 342 x squared y. There we go. Multiplied by x, multiplied by x, multiplied by y. Okay, there you go. Last one. Oh, it was a big number. Negative 1,827. Negative 1 and 1827. Let's check for 3. 2 plus 7 is 9. 9 plus 8 is 17. 17 plus 1 is 18. It'll be 609. This is also divisible by 3. Check using your rule of 3, right? So 203. This is not divisible by 3, nor 5. It is divisible by 7, though. 7 and 29. 29 is prime. I'm not going to give you one this hard on your test, so. There we go. That's it. All right, thank you very much for your attention. Good luck on your final test.